In this video, we're going to look at how to simplify a rational expression. Now, a rational expression is simply a quotient of two polynomials. So we have the first one there, x squared plus 4x plus 4 is a polynomial, and that's divided by another polynomial, x squared plus 3x plus 2. So generally the procedure to simplify, and again you can think of the word simplify meaning to reduce to lowest terms. So that means you want the polynomial or the rational expression, once it's reduced or simplified, to have no common factors other than 1. So if you factor the numerator, factor the denominator, the only common factor you should have, if it's in simplified form or reduced form, is 1. If you consider, say, numerical fractions, so if you look at, say, 8 over 16, for example, we want no factors common to the numerator and the denominator if we're going to simplify it or reduce it. Now, with numerical fractions like this, you can see that 8 will go into 16. So I can write the numerator as 8 times 1, and the denominator as 8 times 2. And then if you have a factor in the numerator and a factor in the denominator, you can cancel those out. And of course, when you say cancel, you're actually dividing these out. So we're saying 8 into 8 goes 1, 8 into 8 goes 1. Let's go at 1 times 1 is equal to 1. 1 times 2 equals to 2 in the denominator. So the reduced answer or simplified answer is 1/2. The only factor that's common to 1 and 2 is 1. So this is in reduced form. So sometimes what we do is we say completely factor the numerator. So we can write 8 as 2 times 2 times 2, or 2 to the third. We can factor the 16 in the bottom as 2 to the fourth, 4 factors of 2. So we have 3 factors of 2 on the numerator, 4 factors of 2 in the denominator. You can cancel the 3 factors of 2 on top with the 3 factors in the bottom. So on top, all I'm left is with 1. In the bottom, I have 1 factor, and that's a 2. So the procedure to simplify a rational expression is basically to factor the numerator completely, factor the denominator completely, and then you can cancel factors that are common to the numerator and the denominator, and what's left will be the answer. One more example here. I can look at, say, 12 over 18. And you should be able to see, again, what you'd have to do. Find the largest number, basically find the largest number that divides the numerator and the denominator, and what's left will be the reduced answer. Now, you can't always do that with rational expressions, but with numbers you can. Numerical fractions. So here I can say this one is a good factor, and say that 2 times 2 times 3. 2 times 2 is 4, times 3 is 12. And in the bottom, I can write this as 2 times 3 times 3. That's 9 times 2 is 18. So notice this cancels, so dividing out. This 2 and this 2 cancels out. What's left? So this 2 times, well, these are 1s actually, because they're divided out, so it's 2 times 1 times 1. What's left is just a 2. And the bottom, what's left is basically a 3. Because again, this is 1 times 3 times 1. Again, this gives me 2/3. If you have a rational expression, let's look at the first one, simplify. So again, simplify means we want this in lowest terms. So we don't want any factors common to the numerator and the denominator other than 1. So what we're going to do is completely factor the numerator and the denominator. So again, we're looking for how to factor a trinomial. I've done some videos on factoring trinomials, binomials, so there's formulas that you need to know. But in this case, it's a trinomial. First thing you look for is, do we have any common factors? Anything that will divide the first term, the x squared, the second term, 4x, and the last term, 4, and we don't have a common factor. So if it's a trinomial, then we have one method that's called trial and error. So we write out two parentheses here. We anticipate two factors here because it's a quadratic polynomial. So we say, okay, factors of x squared are going to be x and x here. And then if this sign here is a positive, assuming this is a positive 1 here in front of the x squared, then both signs are going to be whatever the middle term is. So this should be a plus and a plus. Now if the third term is a negative, then this will have different signs. So it could be a plus and a minus, or a minus and a plus. So now we look for factors of 4, which are maybe 1 and 4. I could put a 4 and a 1, a 2 and 2. So you play around with it to see what gives you the result that you want. So let's try 2 and 2. And then you check to see if it gives you back the original trinomial. So let's see. X times x squared, no problem. 2 times 2 is 4, that checks. Now for the middle term, you want this product right here inside. 2 times x is 2x, and over here 2 times the outer terms, 2 times x is 2x. 2x and 2x is 4x, that checks. So I leave it like that. Now for the denominator, no common factor. So I put my 2 sets of parentheses. I expect 2 factors. If it's factorable, it might not be. And then we look at factors of x squared, again, are going to be x and x. The third term is positive, so both signs will be whatever the middle term is. So again, this is going to be plus and a plus. Okay, factors of 2, you only have 1 and 2, 2 and 1. Okay, so let me try. This case is not going to matter. I can put the 1 here and the 2 here. So again, x times x, multiplying the first terms, I get x squared. Multiplying the 2 outer terms, 1 and times 2 is 2, that checks. And then we multiply the inner terms, that's x, 1 times x, and then this one, last term and the first term here. 2x and 1x is 3x, that checks. Now you see if there's any common factors. So on top we have an x plus 2, but we have an x plus 2 here on the bottom. So this doesn't matter which one you cancel there. So x plus 2, those divide out. So all I'm left with x plus 2 times 1, which is x plus 2, x plus 1 times 1. So this comes out to x plus 2 over x plus 1. This is your reduced solution, or the simplified answer that they're looking for here. So this is it right here. The rational expression has been simplified. Now let's cancel this out here. Now the second one, we have x cubed minus 8. Again, we're simplifying, and we're trying to reduce this to lowest terms. You have the difference of 2 cubes in the numerator. So again, there's a formula for the difference of cubes. You should know this formula. If you're working anything involving rational expressions or just polynomials in general. If you have the difference of 2 cubes, the first factor will always be the difference of the cube roots. Okay, put this in parentheses. So the cube root of a to the third is a. The cube root of b to the third is b. So there's the first factor. That's your formula. And then the second factor will always be, look at the first factor here, a minus b, will be whatever the square is of this first one. Okay, so you square the first term, whatever it is. In this case it's a, so square it. And then you change this sign. If it's minus, make it a plus. Okay, so this is, in this case, minus, so this becomes a plus. And it's the product of these two terms, a and b. So that's ab. And then it's plus whatever the second term is of this binomial here, it's b. You square it. That's your formula. Now there is a formula also for the sum of two cubes. So if this were a cube plus b cubed, the only thing that would change is if this minus right here in the first parenthesis here on the right side, that would be a plus. And this right here in the second factor, the plus AB, that would be a minus AB. That's the only difference between the difference of cubes and the sum of cubes. Change this to a plus, this to a plus, this would be a minus. Okay, so be a plus here, this would be a minus if I change this to the sum of two cubes. So let's look at this one now. Difference of cubes. So x cubed minus a, there's no common factor. Always look for a common factor first before you apply some of these procedures. Don't have one here, and so difference of cubes, the first factor will always be the difference of the cube roots. So the cube root of x to the third is x, the cube root of 8 is 2. Then put that in parentheses. Then another parentheses, and then the second factor, using this formula that I just went over, will be the square of the first term, that'll be x squared. So change the sign to a plus, and then it's this product, x times 2, that's 2x. And then it's plus the square of the second term, this is 2, square it, that becomes a 4. Now in the denominator we have x to the third minus 2x to the second. Again, always look for a common factor before you apply these methods here. We have an x cubed here, an x squared here, so these two terms have an x squared in common. So factor out the x squared. Okay, parentheses, what's left? Okay, if I take out an x squared from x to the third, that becomes just x. Take out the x squared, that just leaves me a minus 2. And then always check to make sure that it makes sense here. So if I multiply x squared times x, I do get the x cubed. If I multiply x squared times a minus 2, I do get the minus 2x squared. So there you have it. So what do we have now? In the numerator and denominator, what factors do we have in common? Well, it's x minus 2 here, x minus 2 here. And again, this x squared cannot cancel this x squared because it's just a whole factor there. Okay, so don't make that mistake. So on top, the only thing we have left is x squared plus 2x plus 4 over, what do we have left in the bottom? X squared. So x squared plus 2x plus 4 over x squared is your final answer. It's the reduced form. Cancel this here. The next one we have, again, simplify or reduce the lowest terms. That's what this means. X squared minus 4 over x squared plus 3x minus 10. Now here we have the difference of two squares. So if you have the difference of two squares, let me write the formula. A squared minus b squared. So if you're doing these types of problems now, you should know these formulas, but I'm just going through a review. If you have the difference of two squares, it factors into, one factor will be the difference of the square roots. So the square root of a squared is a, the square root of b squared is b. That's the difference of the square roots. And the other factor will be the sum of the square roots. And you can check this out by just multiplying the right side out, and you should get the left side. So a squared minus b squared factors into a minus b times a plus b. So now we go, okay, let's factor this out. X squared minus 4, difference of squares. So the first factor will be the difference of the square roots. Square root of x squared is x, square root of 4 is 2. The other factor will be the sum of those same square roots. So this should be x plus 2. Now note, of course, it doesn't matter what order you put these since you're multiplying. You could write it as x minus 2 times x plus 2, or you can write it as x plus 2 times x minus 2. In the denominator, we have a trinomial. Again, no common factors. Check that first. And then we just use basically we're using here the trial and error. Put my two sets of parentheses. And then again, factors of x squared are x. So here, the first factor and the first one here, this will be x. X times x is x squared. Now here, the third term has a minus there. So one sign will be minus, the other one will be plus. So I can put a minus here and a plus over here, or the other way around. I could put a plus and a minus, but these have to be different. And then I look for factors of 10. So that when I multiply these two factors out, I get the original trinomial. So I can use 2 and 5. I can use 10 and 1. So let's see. Let's put a 5 here and a 2 here. And then check it out. So multiply to the first term. So again, to make sure they're the correct factors, sometimes you got to reverse these and you got to get the sign wrong. So look, x times x is x squared. That checks. And multiplying the last terms of each binomial, 5 times a minus 2 is a minus 10. Now that checks, but we have to make sure we get this also. So here we multiply the inner terms. Minus 2 times x, that's a minus 2x there. And the outer terms, 5 times x is 5x. And minus 2x and 5x does give me 3x. Now, if you switched it around, you would get the wrong sign. So all you got to do is switch. Okay, now since I have the numerator and the denominator factored out completely, I look to see if there's any common factors. If there isn't, then all you have to do is say, okay, this is the reduced form. Can't reduce it. It's already reduced. But in this case, we have this factor x minus 2 and x minus 2. What's left on top is x plus 2. Over x plus 5. This is the reduced form, or the simplified form of this rational expression. Let's cancel this in the numerator. Again, that left out the word simplify, but that's what we're doing here, simplify. The numerator, we have, again, a trinomial. So first we look for common factor. We have an x to the third, a 5x, a minus 5x squared here, and a minus 14x. It should be evident that each term has an x in common. So let's take out the x. What's left? Well, we're going to have an x squared minus 5x. Take the x out from the minus 14x, just leaves me with minus 14. Now what do we have in the denominator? We have x cubed plus 2x squared. Okay, so you can see each term has an x, at least one factor of x. So we can factor out, in this case, instead of just x, take out the biggest one that'll come out, x squared. Take out the x squared. What's left? Well, for the first term, I just have an x, because x squared times x gives me the x cubed. Always double check. And for the second term, I'll have an x plus 2. Again, check it. X squared times x is x cubed. X squared times 2x is 2x squared. Now, let's factor the numerator now. X squared minus 5x minus 14. If this doesn't factor, then there's nothing you can cancel out. But this is a trinomial, so again, instead of writing all this again, I'm just going to do it on top just to save some time here. So let me rewrite. X squared minus 5x minus 14 does factor. Again, x squared factors into x and x. The last term is minus 14, so it's negative, so I should have a minus and a plus, or plus and a minus. Order doesn't matter there. So this is minus and a plus. Factors of 14 are 14 and 1, 7 and 2. So let's see, we want this to come out to a minus 5, so I'm going to put the 7 here and the 2 over here, and then just a quick check. Okay, so x times x gives me the x squared. Outer terms, 2 times a minus 7 gives me the negative 14, or the minus 14, that checks. Now the inner term here, product of the inner terms is a minus 7 times x, that's minus 7x, and on the outer term, 7 and x, multiply, that's 2x, minus 7x, and 2x is a minus 5. This checks, so let me just mark this out. This x minus 7 and x plus 2 product replaces this. So what do I have left here? What can I cancel? Well, I have x plus 2 here, and x plus 2. That's going to cancel out. And here I have one factor of x, and here in the bottom here I have two factors of x, so I can cancel this out, this out, but I'm left with 1x. Okay, because x squared is two factors, and the one factor on top canceled out. So what's left for this one? What I have left on top is x minus 7. And at the bottom, all I have left is an x. So x minus 7 over x is the reduced form. Okay, so that completes the video on the simplification of rational expressions. More videos coming up. If you want to see more problems like this, please leave a comment in the description, below the description, or if you want other content, please let me know. I appreciate you watching. We'll see you next time.